Hey guys, and welcome back. In this video I wanted to talk about the RBD secondary RBDs, or the secondary sims, and what we're trying to add here is another level of details on top of everything we've got. And I want to create something that uses particle, that when for example these pieces are separating and fracturing, we get some nice dust falling, and then as comes through, if there is any piece like at the bottom here, we're gonna get a lot of dust as well being emitted. So because of the level of details we have in the sim, if we look at this area for example, you see we're getting a lot of details. A lot of times, depending on what the artistic direction you have, a lot of times this is plenty of information, or visual information to work with. And also you have dust, which I have lowered drastically because I didn't want to hide all these nice details, but in real scenario the dust would be a lot denser and it would cover the scene a lot more. So actually let me show a preview of the smoke by itself. Okay, so this one just showing the smoke from the scene, but it's really low density because I didn't want to hide everything. Let's see if I have another one. Yeah, I don't have it here, but basically this is all everything here is smoke. There is no particle, and I kept the density really low so it doesn't hide anything. But in real life you would want to increase this quite a bit to match realistic preferences, but for me I was just looking at the visual, so I didn't care about the realism. So that's with smoke. But there is another thing that we're going to do now, is using particles. So we want to emit from certain areas from the sim, and these areas is there are two things. There's either the separation of the geometry of the pieces themselves, and or if they hit each other. So if this block for example hits the ground, we want to emit from that intersection. If this geometry here hits all this, if this piece hits this part, we want to emit from that intersection. And so the typical workflow is to use the impact data from the RBD sim. And this impact data is it's going to give you, it's a set of points that's going to tell you the two pieces that are intersecting, or they just impacted together, and it has an impulse, a value that we can check and use. But because we did the two-layered approach, that impact attribute is no longer valid, because we did one sim and then we layered a secondary sim on top, and we changed a lot of things about the active and inactive, and the impact information is not going to be valid. So in a typical, if you were to use a basic approach for doing destruction without the layering, you would get impact information that tells you, hey, this piece interacted with this. And so what you do is you isolate the faces of this geometry and the faces of this geometry, and then you emit from those. Another hack is to use the points and just isolate the area near those points, the impact points, to only make it localized, make the emission localized. But this impact data is not really accurate. It doesn't work really well. So we need something smarter to provide us with this information. So this is one thing, which is the impact and intersection between the pieces. The other thing is the separation. A block can separate from each other without having too much impact on it. So for example, all this part could start crumbling. Maybe here will happen here. No, but I'm looking for an area where the geometry continuously is falling, like this crack here for example, that should continue emitting, or at least emit a certain amount of dust. So the second thing is the separation between the pieces. Okay, and that's another trigger that we want to use, but we don't want to emit constantly. Okay, we don't want to, if this piece separate, we don't want to continuously emit from that. We wanted to emit just once. at the separation time, and then it stops. Now Houdini has a node called debris source. And what it does is it analyzes the connectivity between the geometry in the first frame, stores that information, and then keeps track of it over time. And if there is any variation between the points distance compared to the original frame, then it starts flagging them as emitter, and then it uses a subsolver to accumulate and fade the result. Now the downside with this is very, very slow to use, especially if you want to increase the number of points or emit a lot of points. And it's not gonna work really well with this geometry. It's gonna be a nightmare to use. So you can use it if you want to give it a try, but I'm going to propose something that doesn't require a sim or anything like that. We can do it per frame, and we can submit. If we have multiple machines, we don't have to use a solver to calculate this. We can just batch, and each frame will compute by itself. So the first thing we're going to look at is the intersection between the geometry. Or maybe you should start. Yeah, we're going to start with the separation between the geometry because it's simpler, and then we're going to do the intersection calculation between the pieces and dive more into that. Once we finish all of this, we're going to create a particle sim and dive into that to make it look interesting. Now here I have two sims. One is from the edge, one is the separation, and one is the intersection. Here I believe there was one, it's hard to tell. Yeah, it's hard to see here because I reduced the number of the size of the points. But here you can see it. It's gonna stop after certain points because that's how much I cached. But you can see all these trails, all the dust here. So this is, you can see how much visual it added there. So that's why I said the original one has already plenty of detail, so it's up to you what you want to do. But this one has, both of them has the edge separation and the intersection. And so we're going to start with the edge separation creation first, and then we're going to look at the intersection creation, the emitter between the intersecting pieces. And then once we have the emitter, we're gonna look at creating the pop sim, and we'll go from there. Thank you.